everyone. Welcome to the SaaS Sessions podcast. I have Anupam here with us today. Anupam is a veteran and has over 14 years of experience building and scaling products. We are here to talk about how engineering affects the growth of SaaS companies. Welcome, Anupam.
Hey, thanks, Abhilash. Thanks for having me.
Great. Anupam, I would like to start off by understanding your progress in your career. Like, could you just take us through your career?
Sure. So, I started off my enterprise career as a Java developer, and that started with consulting projects for leading banks and building solutions primarily for investment banking. So, that was my first exposure to the Java world. And after that, what I did was I wanted to move into product engineering. So, I uh, worked with Oracle for some time and worked on their Fusion middleware platform. Again, my tech stack being Java and all related, the whole Java ecosystem along with that. And we were responsible for the foundational layer there in Fusion middleware. So, and which was the backbone of this whole stack, and we provided a hot deployment and upgrade safe that kind of infrastructure to the whole Fusion middleware. And this was also my exposure to version control, source code management, continuous integration, and all the other DevOps techniques. And those techniques were actually we were involved in this, we were using them, but they were not as popular at that time as they are today as whole DevOps world, right? So that was my again experience with the product engineering on how do these products get created. At that time it was more of a so to say, a monolithic application with having components, but a big chunk of code used to get into the main pipeline to actually ship a deliverable. So that was my that experience, and then I started my association with product engineering in a SaaS world after that, and that also exposed to me not only product engineering but also solution engineering for leading banks. And that was also my time in a cloud native SaaS environment, uh, uh, where we build products as a collection of distributed services and following the microservices pattern of software development. So this was my transition from a monolithic, so to say, architecture design to a distributed services, and more specifically speaking into a microservices way of things, and in a cloud native environment where you actually host a SaaS application and try to make it completely cloud native so that everything is auto scales and has advantages of all cloud computing built in. So that's what brought me into the SaaS world and to understand the nuances of the SaaS world, the advantages, disadvantages, and so on. And I currently work as an architect with the multi-cloud management platform, which is again built with cloud native technologies and follows the distributed architecture pattern, which again brings us the advantages of the all new age architecture patterns and technologies around it. So that's what is my current assignment. I think that's about me, about my career, right?
Perfect, Anupam. So I see that there's a vast shift from the time that you've taken steps, progress in your career. Like, whereas everything in the tech world keeps changing. And as you mentioned, like in SaaS as well, everything has changed. What was very popular a few years ago is very different right now. So, like, going into, like, based on your experience, how do you see engineering affect the growth of SaaS?
Yeah, so I would say engineering has a very big and a fundamental role in the growth of SaaS. If we see in contrast to how we used to build on-premise enterprise applications, SaaS brings in a lot of responsibility on engineering to build a stable product, which now not just caters to a dedicated customer, but is open to anyone and everyone to use. So there's a complete big shift in the way we think about products, in the way we develop these products. Engineering has a very big role to play here. If you do not engineer and design the product in the way it is meant to be for SaaS kind of hosting, it is not going to work. So to answer, if does the engineering affect the growth of SaaS? Number one, yes, heavily in a fundamental way. Number two, it is completely from day one that you have to start thinking in engineering how this application is to, if for example, if it's going to be a monolithic enterprise application on premise dedicated for a customer, you design it in a very different way compared to what you would you engineer and design for a SaaS application. So there's a huge influence of engineering on the growth of SaaS, and the engineering techniques adopted to build software directly affects how these SaaS products become stable, how they scale, the adoption of the SaaS approach. The adopting SaaS patterns and techniques by engineering actually makes it much easier and faster to moving to the SaaS model. There's a heavy influence there, right? So I would say, I mean, it starts from engineering, in fact.
Right, Anupam. Very rightly said. And also, from your perspective, like as you mentioned, like while building SaaS as well, when people find that, okay, there is value in creating this kind of product, how does engineering plan for scale? Because when people start out, they might have thought of a few applications for whatever product they are building. But later, based on how people go ahead and use that product, scale also comes into a factor. Like as you mentioned, that the engineering thinks of scale right at the start. How does that conversation generally play out for a company that's just starting out to build their product?
Sure. So you have to start thinking, the companies have to start thinking, the engineering team has to start thinking from day one. But that doesn't mean you create the perfect product on day one. It's a very iterative process. So you think about the product in a SaaS model as much as you can, and you design your application for scale from day one. But never take it as a perfect product or a perfect design on day one. You keep iterating that design based on the real world patterns. For example, one of the pattern which we see in how applications are developed is heavy reliance on synchronous communication between services. Now, if you go that path, such an approach is going against the plan to scale, because the plan should rather be to decouple bigger services to act as independent services. Now, why do we want to do that? Because let's say if you create a non-SaaS product, what you're going to do is you could have even a distributed application, but that could be for a particular customer that has a particular environment that you kind of know how much is the load going to come in on that service, on that product, and you can design and deliver based on that. Now, in contrast, let's see how does a SaaS application work. The moment you go live, you are actually opening it to a web scale traffic. You don't know. You may be very popular. The service may become very popular, and you would see a huge rise in the traffic which you get on these services. So how do you plan for such kind of situation? Unless you go for a distributed architecture, or to be precise, in a microservices way where the services are decoupled with each other, it's difficult to manage that kind of load. So to plan for scale, go in a distributed way, go utilize these technologies, these patterns of architecture, and start thinking on those terms and start building the product on those terms. Although, again, a warning: do not expect it to be the best architecture or to be something which will always work. No, there will be situations where you will see a spike and a service not able to handle that. So you should be able to plan accordingly to auto scale those services. And the biggest advantages, of breaking these services into decoupled services is that we can scale services independently depending on the critical path of the application. That is, for example, in a SaaS application, suddenly there is a huge load on the for example, let's take a very common example of an e-commerce application. There could be multiple orders coming in. There's a sudden sale going on, and there are multiple orders coming in, much more than you expected. You should be able to scale, possibly using auto scaling and all the cloud technologies and the advantages of it, and cater to that kind of traffic. In contrast, if you had a customer enterprise system, in an on-premise system catering only to there, you would never have these kind of problems. So you should break up the services as much as you can around business boundaries, and that's how you plan to handle that kind of load. The second part is try to plan for an asynchronous communication between services as much as we can. Two services talking to each other via it could be a messaging queue, or it could be any kind of infrastructure kept in to have this communication asynchronous. That way, is what you do is you decouple these services. Your response from the first services is much faster to the customer, to the user, as compared to if you go to the whole cycle of the order placement and then come back after a minute or so and then say, okay, your order is placed. So those kind of shifts have to happen at the planning stage on how do we decouple these services and actually make it more reliable as we scale. So those services should be able to handle those requests and give a quick response. And another example to add is you could just take an order and have it submitted for processing, and you could just respond to the user, hey, your order has been submitted. You do not need to immediately inform the user that it is in processing or whatever it happens. It could be deferred a little by going through these asynchronous communication. So that kind of planning does help in actually creating a scalable product.
Perfect, Anupam. Like the examples that you mentioned are very relevant, where we, from like an outsider's perspective, like where we generally see products working at scale. Like we see that when we place an order, everything works as planned. But getting a back-end view of what exactly happens is very insightful. I'm sure that the audience would get a good takeaway from how the entire process works. Following up on the explanation that you just mentioned, I also want to understand when there are products which are built for scale, like where engineering makes sure that if there's a spike, services are auto scaled. Like say as an example, if something breaks, there are situations where there are hot fixes which go out as well. How is that managed with maintaining scale, like for any kind of product?
Right. So, a very good question, I would say. A very important thing in that's kind of distributed. So, let me take a step back and discuss what happens when you break up an application into multiple services and plan for scale and build in a way where these could independently scale and all that. It brings a lot of advantages, but it also brings in a problem that, let's say your service, one of the service breaks, it goes down, it could not handle the load, or there was some kind of failure which caused a crash of that service. Now, it is highly important that these distributed service, when we go into a distributed world, and in fact, if you talk about Netflix scale, you would have thousands of these distributed services doing their own thing. They're just having single responsibility and doing and providing only that service and nothing else. The problem is you should have, sometimes you do not have good visibility into that service. What happened in the system with these thousand services, where the failure happened, and all those things. So when you scale, you have to make sure you have the infrastructure to handle such kind of situation. So the first step is done. You have designed your application in a way where you could handle scaled load, where you could actually handle peak requests and all those situations when you have special sales or that kind of thing, and there is a lot of requests. You have done that job. Now the second thing is building resilience into the application. What happens when something goes bad? Because it's a real world, things will go bad. You cannot make a perfect application. Nobody can. Even Amazon can go down, right? So if we talk about such a situation, how do we minimize the impact of such kind of failures when we scale is building resilience. How do you build that resilience? How do you bring in the stability and reliability? In simple terms, one service failure should not take the complete application down. You should have complete transparency and visibility into the faulting part of the application. And those things are actually that's where all these become very important, that you should be able to see every service's status, the problems, the alerts, and all these things come into. So when you go into a scaling distributed architecture, it's not just one job of just distributed services and done. There are multiple things which you have to support, put in place, to make this very reliable. And building resilience is number one. If, for example, in the e-commerce application we talked about, let's say your ultimate provisioning service, the processing service, which actually tells the inventory and the warehouse that, hey, there's an order, go ahead and start creating the courier details and so on, and pick it up from the inventory and start shipping. Let's say that service goes down. The customer should not see that, okay, your order failed, but rather they should be given a response that, okay, their orders have been submitted for processing. Once the provisioning service or the processing service is up again, and it's able to process orders, then these processing of the all recorded orders should happen, and the order should get submitted, and then we can notify the user that, okay, your submitted order is now ready for processing, and we'll send you the details in some time about the couriers and so on, whatever is the process in our e-commerce world. And it applies to any domain. It's not just e-commerce. It can apply to any health domain or anything. You should be able to bring resilience into the application. It should tolerate the fault, to pick up from fault tolerance, and then go on from there. That way is you don't take the application down, and even if there is a peak, you keep submitting and keep storing the orders, and in a bunch, when everything is again all green and working fine, you should be able to process there. And this connects to our earlier discussion where we see that the services should, that's why, communicate asynchronously, so that there is not a one-to-one direct synchronous communication between these services, and they don't fail when one of the services is not responding. So such kind of techniques, so building resilience, auto scaling infrastructure, such kind of techniques will definitely help you to manage the stability, reliability when you actually increase with scale.
Right, Anupam. That was very insightful, getting the overall picture on how exactly that process is, and how do you actually end up thinking about building it in such a way that in the future, if there is such a scenario, how you can actually go ahead and manage it. So that was very insightful, giving us a broad view, I would say a high level view of how exactly people should consider this. Another aspect that I would like to talk to you about is, what do you think are some of the major challenges that engineering teams face while they deal with growth? Like you mentioned, the process of how exactly the architecture is defined. But apart from these, are there any specific challenges that you would like to talk about based on your experiences?
Sure. So the first and the foremost thing is you have to take some technical decisions, some business decisions when you actually scale, when you deal with growth, right? So most important of them is you reach at a point where you have to do a trade-off. You have to do a balance between the system's stability and your user experience. So that is one challenge which I have seen, which comes not on the day one, but at a little later stage, which engineers have to actually face. For example, the example I was talking about, you have to take a call. For example, let's take a Book My Show, that kind of application where you can book a ticket, you get a response that, okay, your ticket has been booked, you do payments, and then you get a response that your ticket has been booked, and so on. The challenges in such a situation is, if you go and actually book the tickets on the real systems that you could be talking, it could be a PVR cinemas ticket, it could be Inox, or it could be anything else. If you really start doing the complete cycle in this scenario, it would take a lot of time, and you would really not be able to handle that many requests. So to bring it back to our complete discussion about scalability on the SaaS platform, you would really not be able to scale, because you would be taking a lot of time for each request, and your handling of requests, the number of requests you can handle is gonna go down. So those the I mean, in fact, it's a kind of a funny challenge sometimes, because what you make a product for is to give the best user experience, but you don't want a system to go down too. So you do a trade off between a good experience and a good thought behind this. So that's a one very big challenge. How do you achieve user experience and a system reliability balance? So for example, in this case, you could be that you just book a ticket and you say, okay, we on the user, and you say, okay, we are processing your ticket and it should be done. But by the time, let's say, that seat is taken by another request, or even at the PVR counter, right? So how do you handle such kind of situation? So you come back and you say, okay, there is something that seat is not available for the theater. So what do is you do a refund and all that. So these are very later stage problems, but then these are the real world challenges which happen in this distributed and highly scalable infrastructure and the applications which we build today, compared to an enterprise application and on-premise application which we used to build earlier. So that's one kind of a big challenge. You have to identify the balance. That's one thing. Second thing is, when you really grow and you bring this all technical uh, patterns and good approaches, and you have a fantastically running application, it does and you design it for growth. So anytime you have a growth in your traffic and anything, these systems expand on their own or contract depending on if the peak load, like the load is going down or up. Now you have to be very the challenge is to identify the right thresholds where you do these auto scalings, right? So it could be scaling up or scaling down. So you have to identify these thresholds where these changes happen into to be able to handle growth. So those are the more technical challenges which are faced by teams. The third one is around also on the pricing, right? So I want to touch the topic, because if you talk about, and because at some point in our discussion we are contrasting with the earlier way of things of non SaaS, non centrally hosted applications. So what happens in that is, you actually know the cost of your development, you know the cost of your deployments, and so things. You're gonna place 10 boxes in an environment, and those are all accounted for, billed for, and so on. With a SaaS application, the third challenge comes around, how do you price this? Let's say you had a huge amount of traffic, but actually it did not turn into a revenue for you. So let's say you had a million requests, but those did not turn into a million tickets booked or those revenue being generated. So that is just little on the business side also. How do you handle that kind of problem? Because of the SaaS, how do you have your whole system running, you have your whole infrastructure in place, and you are getting built for that, but it doesn't many times convert into revenue. So pricing is one big challenge which teams have to deal with, where engineering is involved, is involved, and it's a tough nut to crack on reaching a pricing point. Not only that, if you go for this example which I just mentioned, you paid for something which did not turn into revenue. So those kind of challenges. So the third one which I touched, is just because it's not just engineering problem always, it's some kind of business plus engineering problem also, which comes with growth. So you want to handle the growth, you expand your infrastructure, everything to handle that growth, but sometimes you have to take a call on the pricing, right? So those kind of things happen.
Thanks, Anupam. This is very insightful understanding the challenges that people generally face, like in such a scenario. Apart from the challenges, are there any tips that you would like to give people who are facing these challenges, how to go about this so that they can deal with these kind of problems?
Sure. So the one of the thing is to earlier on identify the balance which you want to find out later. What happens is, many a times we don't think about such situations, and it's natural and it happens, and it will still happen with some other problem occurring in your system in a real world production scenario. But the thing is to start thinking a little earlier on what happens if your system scales to that level. So I was going through some engineering techniques being applied by companies or the engineering teams which face like a web scale traffic. How do you handle such kind of situations? So you simulate and start mimicking that kind of situations way earlier than you actually get it in real world situation. So it's not always a perfect this thing, but my tip would be to start thinking in those terms once you have a little stable product, and you may not have that much growth, but start planning for that growth. The idea of we will deal with it, we'll cross the bridge when it comes, doesn't work very well in such a situation. It will happen still, but then the idea is to, for example, the balance between the user experience and system reliability. You should start defining at what time, in what situation should I start responding to the user and not have him wait for the complete transaction to complete, and maybe there is a failure and then we don't take payment. So there are pretty new good techniques now to handle such kind of a um, uh, situation. And one technique which I was talking about was a graceful failure. So you do take a payment you from the user, you try to provide that service, something goes wrong, you gracefully go and say to the user that okay, we are refunding just because there was a problem with your order. So those kind of situations we should start to plan when we expect some growth to happen, and not really when that failure happens, and then take a decision on that, which is which is which is ultimately fixing that situation. But a little plan ahead is going to really help on that. And coming on the pricing challenge, that's a little difficult one. But then usually what happens is you start creating your SaaS subscription models around handling these problems. Let's say you have a lot of load, but it did not get converted into revenue. So how do you handle such situations? So for any users, there are various techniques in SaaS pricing models. One of them being you charge a base fee and then let the users use the system, and then when they use a resource, you charge a pay per use and those kind of things. But pricing is a little difficult. Depends on companies to companies. It depends on businesses to businesses, on how do they want to deal with that problem, how much they can absorb for the cause of growth, and not having every user pay and so on. So those kind of things, discuss more. My tip would be discuss more with the business, arrive at a pricing model, specifically in the SaaS world, be it pay per use or with a flat fee plus pay per use, or only a flat fee with some threshold limits. Those kind of things should be, decided a little earlier before actual growth and that kind of traffic comes. But then, having said all these tips are going to help you, but it does not completely solve the problem. The fun of distributed SaaS applications is sometimes you discover things and problems once you go live and you are in a real world situation, right? You could simulate as much as you can in your lab, but that the experience of a production system will always give you some surprise which you have not planned for.
Perfect, Anupam. That really does make sense where you define that, okay, you can take steps to prevent and plan so that systems don't break. But obviously, there are challenges that are coming out every day, and you might face something new and learn something out of it. Thank you for taking your time out. Like, that's our time for today. Thank you for sharing your insights openly and giving us an insight into what exactly happens behind the scenes.
Sure, no problem. You're welcome, Abhilash.
Perfect. It was a great discussion. I really enjoyed understanding your perspective of the challenges people face, and also thanks for sharing those examples. I'm sure that it would help people understand how everything works behind the scenes.